Trigonometry 2, the three main trigonometric ratios for a right triangle. Tangent of alpha equals opposite side over adjacent side. Sine of alpha equals opposite side over the hypotenuse. Cosine of alpha equals adjacent side over the hypotenuse.
Let's have that one more time.
Tangent of alpha equals opposite side over adjacent side. Sine of alpha equals opposite side over hypotenuse. Cosine of alpha equals adjacent side over hypotenuse.
Need a mnemonic?
A mnemonic is a way of memorizing something. If you make your own, and if they are silly or funny, they are easier to remember.
Together or apart, soldiers on horseback charge about heroically. T equals O over A, S equals O over H, C equals A over H.
Surely you can think of a better one than that, or maybe you won't need to.
Tan equals opposite over adjacent. Sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. Can you change the subject of the formula? Do you need the equation triangle? Take a look at the equation triangle presentation if you need to.
Of course, if you are doing trigonometry, you should be able to change the subject of an equation by now.
But it doesn't hurt to use the equation triangle, if it helps.
Finding the sine, cosine and tangent of any angle is easy. Just use a calculator with these functions. Let's do a few examples. This video will use a calculator on the computer. Apple operating system and Windows both have calculators. We will use the Windows calculator because this lesson was made on a laptop using Windows. Make sure you are using a scientific calculator. These have the trigonometry functions. Make sure also that the calculator is set to work in degrees, not radians or gradients. Get to know your calculator. With some, you type in the problem as it sounds. For example, for sine 30 degrees, you hit sine 30 equals. While with others, you type in the number first, then the function. 30 sine.
Use the second method with the computer calculator.
Use the calculator to find the sine of 30 degrees. If you get the answer of 0.5, you're using it correctly. Sine 30 degrees equals 0.5. Now find the cosine of 30 degrees, then the tangent of 30 degrees. Now find the sine, cosine and tangent of 60 degrees. Notice that the answers for the sine and cosines of 60 degrees are the reverse of those of 30 degrees. Notice also that the tangent of 60 degrees is the reciprocal, 1 divided by, the tangent of 30 degrees.
This is not a coincidence, as we are about to show you.
We've already said that the three angles of a triangle add up to 180 degrees. In a right triangle, one angle is 90 degrees, so the other two must also add up to 90 degrees. If one of the angles is 30 degrees, the other must therefore be 60 degrees. Notice that the side opposite to the 30-degree angle is the side adjacent to the 60-degree angle.
And vice versa.
So, the sine of 30 degrees is the same as the cosine of 60 degrees.
And vice versa.
The tangent of 30 degrees is the reciprocal fraction of the tangent of 60 degrees.
The opposite and adjacent simply swap as numerator and denominator.
We'll now look at some special triangles which have interesting sines, cosines, and tangents.
Let's start with a square. To keep it simple, we'll say that each side has a length of 1 unit. The four corners are, of course, 90 degrees. A diagonal line bisects the right angle, cuts it in half. This makes the other angles all half of 90, that is, 45 degrees. The hypotenuse of the 45-45 right triangle, according to Pythagoras' theorem, is given by h squared equals a squared plus b squared. So h squared equals 1 squared plus 1 squared, or h squared equals 2. That means h equals the square root of 2, which is 1.4142.
Now you know all the lengths of the triangle, you know the sine, cosine, and tangent of 45 degrees, at least as fractions.
Just for fun, use your calculator to find the tangent of 45 degrees.
Now let's start with an equilateral triangle. To keep it simple, we'll say that each side has a length of 2 units. Each angle is a third of 180 degrees, or 60 degrees. A line bisecting any of the angles will meet the opposite side at right angles, and will of course make an angle of half of 60 degrees, that is, 30 degrees. The base of each right triangle has a length of half of 2, that is, 1.
Recognize this triangle?
The new line of the 30-60 right triangle, according to Pythagoras' theorem, is given by h squared equals a squared plus b squared. So 2 squared equals 1 squared plus a squared, or a squared equals 2 squared minus 1 squared, which is 3. So a is the square root of 3 equals 1.7321.
Now you know why the sine of 30 degrees and the cosine of 60 degrees are simply a half, and why the tangent of 60 degrees is the same as the square root of 3.
Ow!
The next video will take you through some basic examples. We will assume that you know the formulas of any of the ratios with any subject. The video after that will give more examples with tangents. Finally, we'll look at how to find the angle if you already know the sides.